All right, next example we have here, example 2. We want to find the average rate of change of the area of a circle with respect to its radius r as r changes from. We got a couple different values here. So we'll go through these all pretty quickly here because a lot of this is just arithmetic. But we want to find the average rate of change. So for part A, part B, and for part C, we are not going to be doing any derivatives. This is simply slope formula. So let's go ahead and start off by saying that the area of a circle of radius r is pi times the radius squared. Okay, so now what we want to do here is we're effectively going to be calculating the following. We're going to, for all of these problems, we're going to be doing the average rate of change. So we're going to be doing something like a of r2 minus a of r1 all over r2 minus r1. Or if you want to think of it as like final radius minus initial radius, that's fine too. Here's our start, 2. So r1 would be 2, and r3 would be 3. Our final, or our initial and final radii, respectively. So we're just going to be calculating a lot of this. So here we're going to have, let's see, 9 pi minus 4 pi all over 3 minus 2, which is 5 pi. Okay, so the average rate of change of area over that interval from when the radius is 2 to the radius is 3 is 5 pi. For part B here, we'll have, let's see here, we're going to do 2.5 squared. So 2.5 squared would be 25/4 pi minus 4 pi all over 2.5 minus 2. So after doing some common denominator arithmetic, we can go ahead. I'm just kind of skipping all that. That's all sort of hidden in this equal sign, all that arithmetic. But we get 9 pi over 2, which 9 halves is just 4.5, right? So that's 4.5 pi. So this is still pretty close to 5 pi, but it's getting, it's changing, okay? So let's go to part C here, where we have 2 to 2.1. So 2.1 as a decimal, right, that would be 21 tenths. So if we square 21 tenths, this would be 441 all over 100 pi minus 4 pi all over 1/10, which comes out to roughly 4.1 pi, 41 pi over 10, which is about 4.1 pi. So you can see a trend here. We're going from 5 to 4.5 to 4.1. We're just refining what's going on here. So effectively what we did was we took a bunch of averages. We went from 2 to 3, then we did an average from 2 to 2.5, and then we did an average from 2 to 2.1. And we could have kept going. We could have kept going to 2 to, let's say, 2.001. This is very reminiscent of what we did earlier in the semester when we were using average rates of change on successively smaller and smaller intervals in order to estimate the average rate, in order to estimate the instantaneous rate of change at the one endpoint where we are closing in on. So effectively, parts A, B, and C were gaining better and better estimates for the instantaneous rate of change of the area when r is 2. So now we actually want to go ahead and find that using what we know about derivatives. So this would just be calculating a derivative. A prime of r would be 2 pi r. And if we plug in radius is 2, we get 4 pi, which is exactly what our estimates were creeping towards. So that at least makes sense and checks out.